Hey guys, so in this video we're going to be talking about continuity in a function, and many of you guys probably know that a continuous function is a function that you can draw on a piece of paper without lifting up your pencil, but today we're going to be talking about a more formal definition. So a function f is continuous at a if it meets all of these three criteria. So the first condition is that f of a exists, the limit as x approaches a of f of x exists. In those two values, the limit as x approaches a of f of x is equal to f of a. So the first condition, f of a exists. So if we say a is 0, we know that f of a does not exist. So we know that this is not continuous when at 0. But if we took a point such as negative 0.1, we know that f of negative 0.1 exists. So at a equals negative 0.1, it meets the first criteria for being a continuous function. The next condition is that the limit as x approaches a of f of x exists. So if we know that this condition is true, we know that it's the limit. So these, you might not have seen what these two kind of statements before, but it's similar to like limits. The limit as x approaches a, like with a plus raised, means that the limit as it approaches a from the right hand side. So in this function, the limit as x approaches 2 raised with a plus sign of f of x means that the limit as x gets really close to 2 from the right hand side, because over here from the left hand side it's different, and that's what the minus sign over here is. So the limit as x approaches a from the right hand side of f of x is 4, because it gets really close to 4 from the right hand side when x is equal to 2. But the limit as x approaches a from the left hand side of f of x is 6, because it gets really close to 2, and the value of that is 6 when it gets really close to 2. So in this function, it does a limit as x approaches a of f of x when a is equal to 2 does not exist, because these two are different values, so we can't say that it exists. But if we took a to be a value such as 1, then we know that the limit as x approaches a of f of x is 3, because the left-hand side and the right-hand side approach one value. It's the same value, so the limit does exist in this case. And a function where they do, where the limit does exist, is this function. So over here, the left-hand side and the right-hand side do meet a single point. Even though it's not like a smooth meeting, a limit still exists, because it approaches 2, 4 from the left-hand side and the right-hand side. So in this case, a limit does exist. And the third condition is that the limit as x approaches a of f of x is equal to f of a. So these two values that we were looking at before about whether they exist, they must be equal to each other for it to be continuous. So this is like an empty point, and if we took x to be, or a to be 2, we can see that the limit that f of 2 does exist, so it meets the first criteria. The limit as x approaches a of f of x does exist, so in both from the left hand side it approaches 2, 4, and from the right hand side it approaches 2, 4, so we meet the first two criteria. And the third condition is that the limit as x approaches a of f of x and f of a must be equal. And if we look at it, f of a, so f of 2 in this case, is 1, and the limit as x approaches a of f of x when a is equal to 2, that's 4. So 4 is not equal to 2, so it does not meet the third criteria. So we can say that this function f is not continuous at 2, because it didn't meet all these criteria. It only met 2 of them. And we can say the same thing about this function here. We see that f of a does exist, because at 2, when f of 2 is equal to 6, and we want to see if the limit as x approaches a of f of x exists. So a is equal to 2, but the limit does not exist because there are two different values. The left-hand side has a separate value when it's the limit, and the right-hand side has a different limit. So it does not exist in this case, so we don't even need to bother checking for this condition. So why is this important? Why does it matter? Why does the definition of a continuous function matter? So we know that if a function f is continuous at a, then we can say the limit as x approaches a of f of x is equal to f of a. So if we take a function such as a polynomial, we know that polynomials are continuous on all real numbers, no matter what the polynomial is. So if you're asked to find the limit as x approaches any number of a polynomial, you can directly plug that number into the function, and the limit should be the same as the actual value because we know it's continuous. If we figure out if the function is continuous, we know that this must be true. So we can plug in the value of a to get this thing. So we know that these two are equal for any continuous function. And that makes it really easy to find the limits of functions that are continuous without actually having to do much thinking. So in the next video, we're going to be using these facts and we're going to look at more laws of limits. So thanks for watching.